fifth session of this MCQs on chemical bonding and molecular structure. That's for the discussion of the 53rd question. N2 and O2 are converted as mono anions. The form N2 minus and then O2 minus respectively. Which one of the following statements are found to be correct? So here N2 is converted as N2 minus. O2 is converted as O2 minus. This is 14 electron species, this is 16. As it is addition means it is 15, here it is 7. Here the bond order is how much? 3. Here the bond order is 2.5. Here the bond order is 2. Here it is found to be the O2 minus is actually bond order. What happens here? Bond order from this to this is becoming 1.5. Okay? Let's have first. This is diamagnetic, this is paramagnetic. This is paramagnetic, this is paramagnetic. But this is more paramagnetic first because it contains 2 unpaired electrons, this contains only 1. Now first one. In N2, N bond weakens, which is found to the wrong statement. Bond order is 3, becoming to bond order 2.5 means bond order decreases means the bond weakens. Our bond strength gets which one? Weakens. Means the first one is correct, but we are need only the wrong option. In O2, the O bond order increases. What is the O bond order here? It increases. O2 bond order is 2 and O2 minus bond order is 1.5. Bond order actually gets decreased. Therefore, this is the right option. Let's see the C1. In O2, the bond length decreases. Here, bond order decreases means bond length goes on increase. Therefore, the C is also correct. N2 minus becomes what magnetic? Diamagnetic. N2 minus becomes what magnetic? Diamagnetic. N2 minus refers to which one? The paramagnetic. Actually, it is the we are having the 2 options for this. Both which and which. So actually, it is not a single correct answer option. It is a type of MCQ. It is the multiple answer questions here. So that is why we can expect the 2 that is called as. This is also wrong because N2 minus is becoming what magnetic? Diamagnetic. Similarly, O2 bond length, bond order, what happens? It actually decreases, but here as mentioned this one. Therefore, which and which are correct here? Both B and D are going to be the correct. Okay. Let's have the 53rd, 54. The number of antibonding molecular orbitals or antibonding electron pairs in case of O2 minus, O2 2 minus molecular ion on the base of MOTs. O2 is bond order. It is actually 10 minus 6 divided by 2, that is equal to 2. This is BO, bonding molecular orbitals, and this is anti-bonding molecular orbitals. In case of this molecular mass, then we have only the O2 molecule. O2 is actually 16. O2 2 minus, it is actually 18. Bond order we have mentioned it is equal to, from 16 to 18, the bond order decreases to 1. Means, this is also this. So here, 10 is fixed, minus. If you want to have the bonding or molecular orbitals, it is the same, but the anti-bonding gets increased by 2 means it is instead of 6 it becomes 8. So therefore it is equal to 1. So here as mentioned the number of anti-bonding electron pairs. So this is ABMO electrons. It is equal to 8. Means it is having ABMO electron pairs is equal to 4 because antibonding molecular orbitals is going to be the what? It's actually the first, previously it is 8 electrons. 8 electrons means it is 4 electron pairs. But after getting this one, so here it is going to be the in case of oxygen. But in case of O2 2 minus, the number of antibonding electron pairs is going to be the how much? It is the 4. Because instead of 10 minus 6 by 2, it becomes 10 minus 8 by 2. 8 refers to electrons in ABMO. Electrons in ABMO means electron pairs in ABMO is becoming what? 4. Therefore, the option with respect to that is only the A. Okay. electron pairs, preferably the bonding electron pairs, are present in the white phosphorus. It's actually related to p block element, preferably. But phosphorus, we know that it is a monomeric structure with a linear structure of, sorry, it's a tetrahedral structure. What I mentioned, how many electron pairs, bonding electron pairs are present in the which one? Phosphorus. Phosphorus, we know that it is a nitrogen family, it is having a what? But here as mentioned, the bonding electron pairs. This is one BP, 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 BP. This to this is another BP, and this to this is another BP. Means how many bonding electron pairs are there? 1, 2, 3, 4, 5, and 6. Electron pairs are electrons. If it is electrons means it is actually 12. But electron pairs means in case of it is going to be done. If it is bonding electrons means it is going to be the 12. But bonding electron pairs means it is going to be the 6. Okay? That is 55. Next. The bond order in case of which one? The carbonate ion. The bond order in case of which one? Carbonate ion. Between the which and which molecules? Carbon and then the oxygen is going to be the how much? CO3 2 minus. You have to do before that you have to be very perfect in getting the Lewis dot structure. Directly I will mention that as C double bond O, single bond O, single bond O, minus, minus. So here based on this I am writing that if I put a double bond here, O minus, that is the second resulting structure. If I put the double bond here, making that as single minus, means we are expecting the 3 resonating structures for the switch ion carbonate. So here bond order is also calculated by another formula. Number of bonds between the atoms in the given molecular ion divided by number of resonating structures. This is the another formula to get the what? Bond. The one thing is it is Nb minus N. Means electrons in the bonding molecular orbital and electrons in the anti-bonding molecular orbital. But otherwise, number of bonds between the atoms in the molecule or sometimes it may be the ion divided by number of what structures? Resonating structures. So here how many bonds I can expect? 1, 2, 3, 4. In the next also it is 1, 2, 3, 4. In this one it is 1, 2, 3 and 4. Means in every case how many bonds are there? Actually 4. How many resonating structures that I have mentioned here? It is 3. Therefore it is equal to 1 point. Therefore the bond order with respect to carbonate ion is 1 point. It is an average. Okay. Which of the following is found to be the what magnetic paramagnetic? Which of the following is found to be the paramagnetic? Which is found to be the paramagnetic? B2, it is 5 2s are 10. C2, 6 2s are 12. N2, 7 2s are 14. F2, it is found to be the all are even electron species. Even electron species are found to be the what magnetic? Diamagnetic. But I have mentioned the two numbers. What are those? 10 and 16 are found to be the paramagnetic, even though they are found to be the even electron species. Therefore, which is found to the paramagnetic behavior, it is the 10. 10 means it is minus what? Boron. Next, correct order of bond length is. What's the correct order of bond length is in case of carbonate ion, carbon dioxide, and then the bond order for carbonate is just now I have mentioned it is equal to 1.3. In case of CO2, it is having a C double bond O, double bond O, means it is equal to O because it is double bond C. If it is found to be the which one, the third one is what is that? It is a carbonate, okay, carbon dioxide and then carbon monoxide. Carbon monoxide structure is C. Triple bond O plus and then the minus. Here the bond order is going to be what? How bond order is related to this? It is inversely proportional to bond length. This is according to the number of resonance structures, and then the number of bonds we have calculated that as 1.33. And it is a standard carbon dioxide is having a double bond with the oxygen. And in case of this one, it is an odd electron species. Sorry, it is a pseudo electronic species such that the bond array is going to be the what? 3. Now, on that basis, we can say that it is 14. 14 electron species means it is nothing but bond order is how much? 3. So, with respect to bond order, what's the order here? Bond order is CO is greater than. Next is CO2 is greater than CO3 2 means. If it is in case of bond length, they have mentioned it is less than this. Means CO3 2 minus is greater than CO2 is greater than CO. Therefore, the option with respect to that is going to be the 58. Okay. Next, contrary to other hydrogen halides, HF is found to be the liquid. Right? All the hydracids of hydrogen is found to be the hydrogen halides are going to be the gases except HF. Why? Because the very strong reason that is that there is a strong Witch bonding, hydrogen bonding, such that the molecules gets close to each other. That closest makes the gaseous nature of HF to the water nature the liquid nature. Therefore, HF molecule are going to be the what bonded? Hydrogen bonded. Okay. The maximum possible number of which one? The hydrogen bonds in which an H2O molecule can participate is how much? One H2O molecule can involve in how many hydrogens? Hydrogen bonds. As if we know that this is V-shaped molecule, this is partial negative, partial positive and partial positive. So during the formation of hydrogen bond is the electrostatic force of attraction with the hydrogen, the most electronegative atom. Suppose if another water molecule comes here, H, O, H, delta plus, delta minus, delta minus, plus. There is another possibility here, H, single bond O, single bond O, delta plus, delta plus, delta minus. Okay? If I come across this, it becomes O, H, H, delta minus, delta plus, delta plus. If I come across this, it becomes O with H and H, delta plus, and delta minus. Here, one molecule of water is linked to how many water molecules through the Witch bonding? This is Hb, this is Hb, this is Hb, and this is also Hb. Therefore, how many hydrogen bonds we can expect from a single water molecule is not with that. Suppose the same question. How many chemical bonds are exhibited around the oxygen atom in water molecule if they ask, or in case of ice? Oxygen is covalently bonded to 2 plus 2, in which 2 are covalent bonds and 2 are hydrogen bonds. With respect to hydrogen, this is also hydrogen. Suppose if I take this oxygen atom, this is covalently bonded to 2 hydrogens and this is hydrogenly bonded to 2 hydrogens. If it is in case of the water molecules, or it may be the number of hydrogen bonds in the water molecules, or it may be the number of bonds that has been exhibited by the oxygen atom, both will have the same option of D. That's what I have for. Okay. Strength of the hydrogen bond is intermediate between. So usually we have mentioned the coordinate bond. Which one? The coordinate bond is a property between the ionic bond and then the covalent bond. It's ionic bond and then the ionic bond and then the covalent. Hydrogen bond means it is found to be the covalent bond and then the van der Waals bond. Means hydrogen bond is intermediate between the which one? The weak van der Waals bond and then the strong which bond? Similarly, if they ask for coordinate bond, the coordinate bond is the intermediate between the strong ionic bond and then the weak which bond? So on that basis, can I mention here like this? Hb is greater than Vb. So which is the strongest here? It is the ionic, and the weakest is going to be the which one? The van der Waals bond. Okay. Next, in which of the following compounds intramolecular hydrogen bonding is present? Intra means within. The best examples for intramoleculars are orthonitrophenol, salicylic acid, salicyl aldehyde, This is inter. Ethyl alcohol, water and hydrogen sulfide. First, this doesn't have the what? Hydrogen bonding. And these two are what? Intermolecular hydrogen bonding. But this is going to be the intermolecular hydrogen bonding. So that is for example. So here, this is benzaldehyde. Salicyl aldehyde, salicylic acid or salicyl aldehyde. Suppose if I mention here like this, single bond H, double bond. What is this? Salicyl aldehyde. Oxygen is more electronegative than carbon. Similarly, hydrogen is more electropositive than oxygen. Therefore, they are this one and this is called as. Means the direct answer that we can have the very best examples related to the intramolecular are orthonitrophenol, salicylic acid, and then the which one? The salicyl aldehyde. Okay. The boiling point of a compound is raised how? Boiling point means during the breaking, during the heating, the molecules has to separate. So that is called as the boiling point nature. Means either there may be a presence of weak van der Waals interaction or it may be sometimes the strong hydrogen bonded nature. Means it is not the intra, it is only the inter. Therefore, the boiling point can be increased or can be raised. That is due to the presence of which one? Intermolecular hydrogen bonding, but not the intramolecular hydrogen bonding. Okay? The boiling point of a compound is raised only by the intermolecular which bonding. It's a very best example related, that is called as anomalous behavior of which one? Water. Water is having an intermolecular hydrogen bonding. Okay? The enhanced forces of cohesion in metals is due to the covalent linkages between the atoms, the electrovalent linkages between the atoms, the lack of the exchange of the valence electrons, the exchange of energy between the arc of the mobile electrons. Metal. M is a metal atom. And this is called as a lattice, that is called as metallic crystal lattice. And this is called as MB, that is called as metallic bonding. How the metallic bonding creates? As we know that the metals are highly electropositive in nature, they readily lose the electron to form respective cation. So here, M plus M plus first, they will have the water, repulsion. But due to the cohesion force that has been existing, that is, the electron cloud of this is attracted not only to this but also towards this, such that these molecules come in contact with each other, and that results in the metallic. Means it is just the exchange energy of the which one? Moving electrons. Moving electrons is called as mobile electrons. And these particular is called as kernels. What are kernels here? They are the metal cations of the same metal is called as kernels. Means means there is a net force between the two kernels, and that is due to the presence of exchange of energy between the what electrons, the moving electrons. That is observed in case of the metallic. Okay. Which of the following statements is found to be the true? It's the true statement regarding that. That is, HF is less polar than HBr. Absolutely pure water doesn't contain any ions. Chemical bond formation takes place when the attractive force overcomes the repulsive force. In covalency, there is a transfer of electrons. HF, HBr, negative partial, partial positive, negative partial positive. So higher the electronegativity, more is the polarity. Lesser the electronegativity means lesser is the polar. Therefore, true statement. HF is more polar or less polar? Less polar. Sorry, more polar, but less polar is the wrong option. Absolutely. Pure water doesn't contain any ions. As if I know that. Now we know that. At 25 degrees Celsius, H2O gives rise to H plus and then OH minus ions. Here alpha is 10 to the power of. Even though it is less, no doubt. Its degree of dissociation is less, but there are some presence of which one H plus and then the OH minus ions. Therefore, this is also wrong. Chemical bond formation takes place where which forces are? The force of attraction is dominating over the force of which one? Repulsion. This is called as net interactive force, and that net interactive force is resulting in the formation of a which bonding chemical. So therefore, option is not. In covalency, there is a transfer of electrons. Covalent means it is the sharing of electrons, but not the transfer. Therefore, it is the C is the correct option with respect to that 65th MCQ. Okay. Blue vitriol has. What is blue vitriol actually? Blue vitriol is actually called as copper sulfate. Pentahydrate is called as blue vitriol. Blue vitriol. This can also be mentioned in the form of, according to the theory of Werner's, H2O4 times SO4 dot H2. This is the original structure. Because H2O is now acting as a ligand. Here it is 0, here it is 2 minus, here it is 2 plus, here it is 0, here it is 2 plus. First, between them, it is ionic. This one to be the ionic. Between Cu2 plus and then this one is found to be the coordinate. And in case of H2O molecules, as if I mentioned, it is having a intermolecular which bonding hydrogen. Then in H2O molecule, it is also again by the covalent bond. And that covalent bond is particularly the covalent bond. Means copper sulfate pentahydrate contains ionic bond, coordinate bond, then the hydrogen bond along with the polar bond. Therefore, we can expect all. Okay. Next is the values of electronegativity of the atoms called as A and B are respectively 1.20 and 4.0 respectively. Therefore, what is the percentage of which character? Ionic character in the AB bond. How to calculate the ionic character? Percentage of ionic character. One thing is 1 minus e to the power of 4 into Ea minus Eb is one option. The other is 16 times the electronegativity of A minus electronegativity of B, or Xa minus Xb, plus 3.5 into Xa Ea minus Eb. Difference in electronegativity. Okay? Sorry for the disturbance. So sorry for the disturbance. So now we move on to the what? 68 questions. The values of electronegativity of the atoms which enrich Ea and Eb are 1.2 and then 4.0 respectively. The percentage of ionic character of A and B is how much? AB bond is how much? Previously we have calculated for the ionic bond, percentage of ionic character in various methods. Dipole moment of the experimental divided by dipole moment of the theoretical are called as expected. Or we can have that in the form of percentage of ionic character is also equal to root of x square plus y square plus 2x square into cos of theta, where theta is the inclined angle for the two different dipoles. Okay? So then another thing is, by knowing the value of E, that is 1 minus e to the power of 4 into xa minus xb refers to the which one? Or A minus EB refers to the percentage of ionic character. But here in case of this one, it is given in the form of the difference in percentage of ionic character. Here, percentage of ionic character is now calculated by the formula. What's that? Is equal to 16 times the xa minus xb, or here it is xb minus xa, because which is greater than here? Which is greater than here? B is greater than A. Therefore, it is xb minus xa plus 3.5 into xb minus xa in terms of whole square. So here the difference of these two is, I think it is 2.8. 2.4 minus 1.2, it is becoming what? 2.8. That's equal to 16 into 2.8 plus another is 3.5 into 2.8 in terms of whole square. Don't simplify to your largest extent. Okay? So assume that it is nearly 3 right now. 3 square is 27. That is 3 square is 9. 9 3s are 27. 9 with 0.5 it is 27 plus 4.5. Nearly 31.5 is approximate. What 31.5 is? It is not. If I take approximate value as 2.8 is nearest equal to 3. 3 square is actually 9. 9 3s are 27. 9 into 0.5 is actually 4.5. 27 plus 4.5 is 31.5. Now, here, assume that it is nearly 3. It is not exact. 16 3s are 48. 48 means it is nearly 46 or 47 or nearly 45 you can say. So, approximate difference is above 70. Above 70 is going to be the 72.2. Because it is not the exact value that I have mentioned here. Instead of 2.8 that I have taken, how much it is done? 3. But here it is not exactly 31.5, it is actually less than that because it is 2.8 whole square. So similarly here also we can take that as, instead of 48 I just mentioned that in the form of 45. So by simplifying we can get the nearest value as it is actually the greater than 70. Among the 4 options we are having, it is the 72 point how much? 24. Okay. Next. The number of electrons that are paired in the oxygen molecules, without any calculation we can directly mention. How many are found to be the paired electrons are present? How many unpaired electrons are present in oxygen molecules? Oxygen is actually 16. 16 among that, how many unpaired electrons are there? 2. Therefore, how many unpaired electrons are there? Sorry, paired electrons are there? It is equal to, or if I need that, oxygen has 2 UPs and 14 P's. Because as if we know that it is 16. 16 refers to sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 is equal to pi 2py2. Then pi star 2px1 is equal to pi star 2py1. 2, 10, 10 plus 2, 12, 14, 15 and then 16. So here, 1 refers to their unpaired, means how many unpaired electrons are there actually? If 2 are the unpaired electrons, the rest 14 are going to be the what electrons? Paired electrons. Okay? So this is how we are going to calculate the number of electrons that has to be paired in a given molecule called as, for example, oxygen. Okay? So I think I have discussed the major portions or major concept in all the chemical bonding concept, that is chemical bonding and then the molecular structure. That is, we have discussed all the different 6 different types of chemical bonds. That is ionic bond, covalent bond, then coordinate bond, hydrogen bond, metallic bond, and finally the biggest one that is called as van der Waals bond. Okay, based on that, that is usually in the competitive sections, the major questions that has been asked usually in the hybridization case, not directly the hybridization they will ask what is the geometry of that. That the geometry is decided by the nature of hybridization, which is given by H is equal to what? Half of V plus M minus C plus A. What is V there? Number of valence electrons on the central atom are the key atom. What is M? The number of monovalent bonds that has been bonded into the central atom are the key atom. What is the C? It is a charge with respect to which one? The cation. Whereas A refers to the charge on which one? And based on the H value, if H is equal to 2, it is called as sp hybridization. If H is equal to 3, then it is sp2 hybridization. If H is equal to 4, then it is either sp3 hybridization or it may be the dsp2 hybridization. If H is equal to 5, we can expect in the form of sp3d hybridization. If H is equal to 6, then it is going to be the octahedral, octahedral. And finally, if H is equal to 7, it is sp3d3 hybridization. So those hybridization doesn't exactly decide the geometry. If and only if this is satisfied, which one? Only the bond pairs are possible, means we can expect the exact geometry for sp is linear, sp2 is trigonoplanar, sp3 is tetrahedral, dsp2 is a square planar. If it is sp3d, it is a trigonal bipyramidal. If it is sp3d2, means it is called octahedral, and finally sp3d3 means it is going to be the pentagonal bipyramidal. But the main limitation with respect to VBT is the presence of the which one? Lone pair of electrons. What the presence of lone pair electrons has mentioned that? So the presence of lone pair of electrons has mentioned that the repulsion always changes the first bond angle. If it changes the bond angle, means it again changes the geometry. That is why we are having the 3 different repulsions in case of BS theory concept. That is, lone pair repulsion is always greater than the lone pair with the bond pair repulsion followed by the bond pair with the bond pair repulsion. So that lone pair always changes the geometry of the molecule. Even the value of H is always going to be the same for the different molecules. Okay, so that is the main concept behind the VSEPR theory. And another important question that has to be compulsory asked is the electronic configuration of a molecule, or it may be the molecular ions, which has to be explained on the basis of MOT, that is molecular orbital theory. Okay, we didn't have the major concept of writing the electronic configurations in everywhere. You must take the 2 standards, that is called as one is oxygen and another is nitrogen. Because we are having the 2 different configurations. One is oxygen and beyond oxygen is one case, and the second one is nitrogen and beyond nitrogen. So that is, beyond nitrogen means either it may be in the form of carbon molecule or it may be the boron molecule. Okay, so after oxygen is the regular. The difference in that one is, in case of oxygen, sigma 2pz is first filled, that is lower energy compared to that of pi 2px and pi 2py. Whereas in case of the nitrogen, first comes the pi 2px and pi 2py followed by the sigma 2pz. Okay, so now how we have the bond order resemblance of the recognition here, taking 14 electron species as standard. What's that? It is 14 means it is 3. 16 oxygen is what? 2 bond. Means what is 50 now? It is 2.5. Means from 14 to 10, the bond order regularly decreases by 0.5 unit, and finally at 8 it reaches to 0. Whereas similarly, from 14 to 20, again the bond order gets what happens? Decreases from 3 to 0 with a difference of 0.5 unit for every increase in one electron species. Means the standard at the center molecule that has having the maximum bond order is what? 3 for the nitrogen molecule. Means not only the nitrogen molecule, we can say that it is either the Cn minus or it may be the Cn. What is that actually the? Similarly, we can have the O2 2 plus. Similarly, we will have the C2 2 minus. All will have the isoelectronic in nature with a bond order of exactly equal to how much? So this is very important. because the time is very less, or we can say that the time is very important to doing the solving of the multiple choice questions in the competitive examination. That is why you have to have the very key points. Without solving or without having the grand discussion of that particular multiple choice question, just you observe the what the key that has been present in that MCQ and get the immediate answer as fast as possible. Because according to this one, in NEET, we know that it is 1:1 ratio. Okay, even in the CET also we are having 1:1 in the ratio. But in case of which one? The JEE means it is usually more than 1:2. 1:2 more than 2 is the case, because according to the new concept, we are having 25 MCQs for each subject of B, C, and then B. So so that at least minimum 2 minutes we will get in case of the JEE means, whereas they are in the ratio of 1:1 in case of the CET or maybe the B. So be careful and get the brief synopsis very clear, because once if you get the clearness in the synopsis concept, you can immediately answer those questions without having the lengthy concept, without having the writing of all the structures or all the electronic configurations or all the bonding and then the anti-bonding electrons that has been present in the molecule or maybe the molecular species. So be careful and get the very key concept as one of the major highlighting in case of the chemical bonding and then molecular structure. So I think this completes the most important topic for the competitive examination in the form of chemical bonding and then the molecular structure.